All right, welcome back to the channel, everyone. Today I want to introduce you to the concept of binning data or putting data into discrete buckets. Okay, so if we have a lot of continuous data and we need to do some analysis on this can actually help us with all kinds of analysis, right? Because we'll take a very large, very diverse group of continuous data points. These could be people's ages, it could be temperature ranges, it could be anything numeric, right? And if you want to condense that into a smaller, easier to work with, summarized set of data, binning is a great way to do this. It's actually kind of similar to group by in the SQL world. You can group by in the Python world and in the SQL world, and binning is very similar to this concept. So if you've worked with that before, then you should be up to speed with this in no time at all. So when dealing with continuous data, basically we want to create this into discrete buckets or discrete bins for a few different purposes. For data visualization, to overall simplify the analysis, just make it easier to work with complex data sets. We can create new features, right? So feature engineering is creating new columns or new features from existing columns or existing features. A column and a feature is the same thing. For segmenting data into different buckets and for handling outliers, right? So if we have a few outliers and we don't want to analyze that because that is going to give us some wonky results for analysis, we can easily kick those out. But the opposite could be true. Maybe we want to understand what's creating these outliers and we want to focus just on the outliers themselves. Okay, so there's a couple different ways to take this. It really depends on the type of analysis that you're trying to do. So here is my data set. I will import that, Control Enter to do the import. I'll show you where the data comes from at the end of the video here. I put a link that describes where you can download this data from. So you can see the columns here, or features. I like to call them features. Some people call them columns. Account number, name, SKU, quantity, unit price, EXT price. Not even sure what that is. Extended price, probably EXT price. You'd have to go into the data dictionary and see exactly what that is. Offhand, I don't even know. So we can see the head of the dictionary, head of the data frame, sorry, and we're going to plot the results from this data frame. This is the data frame. This is EXT price. We'll call this external price. And we are going to look at the counts of discrete bins. I set this to 25 bins. This could be anything you want, right? If I do this, we get 10 bins. Okay, and that's how the data is distributed. So we actually have about 28 that have no external price, and there's one over here that has a price, or 6 that have a price between 4,500 and 5,000. And again, this is very flexible. You can set this to whatever you want. So you would change that variable, and then you get 25 buckets. So again, 28 that are just zeros, and we have one that is way off here on the tail end of this thing here, and I think that's 5,000. Get up to 5,000 somehow. So it falls into that bucket, and then it gives you the frequency or the count of all of these numbers over here, and that's coming from that. So if we didn't bin these or bucket these, we would have probably 1,500 discrete number sets over here. When we put it into 25 buckets, we have this just 25 buckets that we can work with. So it's probably easier to work with this once it's binned. So let me go ahead and refresh this cell and we'll see what we get. Okay, so now this concept is called a qcut. This is a pandas qcut. This is probably the simplest way that you can use this type of thing. And you can see all the counts are the same. So we have 375 items here into 4 different bins, okay? And I'm telling it, assign these labels, low, medium, high, very high, drop in duplicates. We don't have duplicates, okay? All these numbers are unique and distinct. And I am printing value counts. That's how we're getting these over here. So we have 375 items in each bucket. So it's equally distributed, okay? And that's important. You'll see why in a second. This is creating quartiles and deciles for me. So again, I'm taking this data frame, appending a new column here called quartiles, and I'm saying to this thing, give me 4 equal counts of quartiles, and I don't care what the range is. The range can be whatever it is. I just want equal numbers. We saw that 375 just a moment ago. So here we're getting the same thing, but deciles. So instead of 4 different buckets, we will have 10 different buckets, okay? And they will all have the same number of counts as we saw before. And if I refresh this, you'll see exactly that. Okay, so we have 375 quartiles, 375 items in each bucket and 150 deciles because we have 1,500 records, 1,500 unique, distinct records. Okay, so I think that is pretty self-explanatory there. One of the challenges with this approach is trying to, convince or communicate to shareholders what's a quartile and what's a decile. Like we'd have to create a couple PowerPoint slides and show them this, and then make sure they're on board with this kind of nomenclature, right? If you want to approach it a different way, you can actually assign different labels to this data based on the rendering of the number of buckets we have. So here I have quantile, so this is 5 buckets, and I'm saying anything within this range, the lower range is going to be bronze, this is going to be silver, 0.2 quantile, 0.4 is going to be gold, 0.6 is platinum, and 0.8 is diamond. Okay, so I'm sorry, between these ranges, right? Because we have 1, 2, 3, 4, 5, 6, and 5 quantiles. Okay, well, it's always zero base, so it starts with that. It's going to get everything within this range, everything within this range. But here's range number 3, here's range number 4, and then finally range number 5. So anything that falls within those ranges is going to get assigned these labels. So that's pretty cool. Now, there is a major distinction between the qcut and the pandas cut. So let's take a moment and try to understand that. Okay, so all bins will have roughly the same number of observations, but the bin range will vary with a qcut. Okay, and if you do pandas cut, you specifically define the bin edges. So there's no guarantee about the distributions. We saw before we had 150 in those deciles and 375 in the quartiles, right? So the number of counts in each record is probably almost certainly not going to be the same, right? That's what a qcut would give us, but a cut is going to give us the same range size. So cut gives you the same range size, qcut gives you the same number of data points, okay? So it's important to make that distinction. It is subtle, but it's very important too. So here's the pandas cut demoed for you. Let me do Control Enter. Okay, we can see exactly that. So now we're controlling the ranges, but the counts are going to be very different. So you have 793, 425, 217, 65, and I plotted this. I always tell people a picture is worth 1,000 words, so this is very easy to see. The numbers represented in a bar plot. Okay, so here's 793, 425, 217. That's what you see right there, 425, 217. The last one is coming up with 65. Very nice, we got that. So I think we are in good shape here. Here's another example of pcut. So one of the challenges is with defining the bin range. Okay, so with the qcut, this is done for us automatically. With the cut, you have to do that yourself. Okay, so again, we're looking at the external price, and we refresh this, and we will get the data cut out for us. Okay, here's the ranges like we saw before. Okay, so that is very useful. And then here's one more example, and I think we kind of just saw this, right? Those 793. Yeah, I'm going to delete that because we already had that. I don't want to duplicate anything. That was a mistake, I think, because we already did that right over here, and we explained how that works. So that's kind of it. It's pretty fun. It's pretty cool. It's not hard at all. This is the link where I found the data, so you can go there. I'll put that in here and share it with you. You can find the data right over there. Okay. And I think basically, how do I do it? I go over here, download raw file. That was it. You just click that button to download this data, and then you suck it in right at the beginning, and you do your analysis. So that's pretty much it, guys. That is binning data or bucketing data using pandas data frames, qcut, and cut. I'm going to wrap it up here, and I'm going to post a video in just a little bit. Hopefully, you learned a couple new tricks here today. I certainly did myself. Okay, so thank you for your time, and enjoy the rest of your day. Goodbye.